Good everyone, my name is Graphics. Today we want to solve this exercise in electrical engineering science, and the question is posted at the top right corner of the screen. Now if you look at what is there, let me show you in a bigger picture. Now look at the front of the screen. We have different currents. That is what we call this a network, right? We have different currents. We have I1, I2, I3, I4, I5 at different points given. Now we're told to calculate the value of the current marked. What I mean is I1, I2, I3, and so on and so forth. Now the only way we can, one of the ways, or the only way we can really look for the value of the current marked is by applying KCL, kirchoff current law, right? And what does the law say? The law says that the total current entering into a node is equal to the total current leaving the node. That means the algebraic sum of all current into a node is equal to what? 0, right? So what I simply mean here is that if I have a node this way, right, and a current, let's say this is a current, let's say I1 is entering, another current, let's say I2 is entering, another current, let's say I3 is leaving, another current, let's say I4 is entering, right? This guy you see here is called the node. The node is the point where two or more currents meet. Now the KCL, the kirchoff current law, is telling us that the current entering is equal to what? The current leaving. So let me assume now, let me say this is enter and this is what? Leaving. I will call it exit. This is my equal sign. So let's say the current entering, I1 is entering, I1 will be at the point of entrance, I2 is entering, then I'll add it with what? I2, I4 is entering plus what? I4. Now where's the one leaving? I3 is leaving. Look at the arrow is leaving, so we'll write the I3 here, right? Now let me just add one to it. Let's say we have like you coming here, let's say I5. Let's say I5 is also what? I5 is leaving. So because it's leaving, I'll put I5 here. All together now. So the current entering into this particular node is equal to the current leaving. That is the law of, as we call it, KCL, kirchoff current law. Or we can say the algebraic sum of all current entering the node is equal to what? 0. Any of them we want to do. So if this is come to the other side, it will be I1 plus I2 plus I4. When I3 is coming, it will become minus I3. When I5 is coming, it will become minus I5, right? So this is equal to what? 0. This is what the KCL is telling us about. Now let's go back to our question at the top. Now we have a lot of nodes here. Point A, look at letter A there is a node. Letter B is another node. Letter C is another node. Letter D, letter E, and F, they are all nodes there, right? So for us to calculate for I2, I2 is connected to node A, right? So what we're going to say now look at, I'll move this in the front of our screen. This picture now, let's look at the top right corner of the screen here. Let's see how it goes. So you write that at node A, at node what? Node A, right? So the current entering is 30 ohms. So I'll put my equal sign and I'll allow this right hand side should be, I'll write it small. This is exit, right? And this is what? Entry. Is that making? So from here, 30 amperes at point A, look at, is entering. Is that taken? So I'm going to put the 30 at this point. Are we good? 10 is also entering. Look at this arrow facing, pointing at that point A, just like the way 30 is. So plus what? Plus 10, right? And what is leaving? I2 is leaving. It's pointing away from that A. So it means it's leaving. I'm writing my I2. So it means that my I2 is equal to what? 40 amperes. Is that okay now? So we've gotten my I2. Now similarly, if you look at node C, right? So similarly, if you do for that of what? Node C, we have I2, I have my entry. You don't really have to write this, I'm just going to show you. And I have my what? My exit, right? So at the entry, I2 is pointing to C. Since we are considering node C, I2 is pointing to C, so it means it's entering. So I'm going to put I2 here, right? I1 is pointing to node C, means I1 is entering. So plus what? I1, right? Then the 100 amp is leaving. It pointing away, the arrow is pointing away from C, means it's leaving. So I write what? My 100 amp. But I2 is equals to what? 40 ampere from here. So I'll substitute it here. So we have 40 plus I1 is equals to what? 100. So my I1 is equals to what? Is equals to 100 minus 40. So the I1 is equals to what? 60 ampere. Right? Now if you look at similarly, we have another joint which is called joint D. After C we have D. So let's consider, let us do it around here. Let's say we have node D. Node what? Node D. It is not giving the attribute 1 here. So at node D, right, we have the same thing, we do the same thing, we have entry, and we also have what? Exit. Is an equal sign. So 100 is pointing to D, so it means 100 is entering. 20 is pointing to D, look at the arrow, means 20 is also entering. Then I3 is pointing away from D, so I3 is what? Leaving. So I3 is equal to what? 120 ampere. Are we together? Now if you look at, we want to calculate for I4. Now you look at that joint F here. At F, you discover that at node F, right? So you discover that there is a node F at the last point on that straight line. Node F. This is A, B, C, D, E, F. At F, we discover that 20 is pointing away. So I have my entry. You don't have to write entry. I'm just using this to show you what to do. I'll have what? Exit. So at entry, 20 is pointing away from F, so it's leaving. So 20 will be here. Right? Similarly, I4 is pointing to F, so I4 is entering. Right? I5 is also pointing to what? Is pointing to F. So I5 is what? I5 is entering. Plus what? I5. Right? Now if you look at this very well now, we have two unknown. We don't know I4. Similarly, we don't also know I5. So I can just decide to call it an equation. Let's say equation 1. Right? But instead of considering node F, why not consider node E? Let's see. At node E, that will have little unknown. Let's consider node E. At node E, we discover that I3 is pointing towards node E, right? So I have my I3 is entering towards node E. I4 is pointing away, so it's exit I4. Then 20 amp is pointing away, is leaving, so plus 20. Is that okay? Now from here, we know what I3 is. I3 is 100 and what? 120. I write my 120. Then equals to what? I4 plus 20. So when this 20 is coming to this side, it will be 120 minus what? 20 is equal to what? I4. So from here, I4 is equal to what? 100 amp. So we've gotten I4. So now I can put I4 into equation 1 to get what is called I5. So what I'll do is, I'll say substitute substitute I4 equals to 100 ampere into equation what? Equation 1, right? So equation 1 is telling me I4 plus I5 is equals to what? 20. So what is I4? I4 is 100. This is 100 here, right? Plus I5 is equals to what? 20. So my I5 will now give me 20 minus 100. So my I5 is equals to minus what? Minus 80 amp. Now the negative is telling me that I5 is going in the wrong direction, right? So we need to change the direction of I5. So instead of it pointing towards joint F, it should be pointing away from joint F. Is that taken now? So if you found this video helpful, please don't forget to click on the subscribe button and also click on the like button. Thanks for watching.